All right, everyone. Welcome back to Advent of Code series. Um, this year we are off to an earlier start, but still a late start because I got a little bit lazy with recording and just have been busy with some other things related to work and other commitments. But I'm glad that we are back in business with the recordings because this is one of my favorite parts of the year and the competition. So, today we're just going to go through day one. Last year I recorded these solutions in C++. plus plus. This year I am doing them primarily in Rust, but also I have a goal to record solutions in C++ plus plus and Python, but that goal may not be met because these recordings take a fair amount of time. Not that they're like of any sort of notable production quality or anything, but just that, not only do I have to implement the solution, I also think about things to talk about and mention, and then of course do the recordings themselves. So, sometimes just it doesn't work out with the timing, but I will try to put out solutions in other languages, and I will try to get all the way to 25 days this year. So, with that said, let's dive right into day one. And I'm not going to read this whole preamble here because this is, just kind of telling you that the goal is to reach 50 stars, kind of giving you the storyline or whatever. Sometimes they're a little bit fun and interesting. Eric, the guy that puts this together, he does, he puts a lot of effort into it. So I recommend, you check this out on your own. But I just kind of want to dive right into the solution. So basically, in this task, we are given two lists of numbers, and the lists of numbers are presented side by side. So this is going to make parsing them a little bit strange because normally, when you get lists of numbers, they might be comma separated on two different lines, or just this is, I would say, not a super standard format, but no worries, we can get through that. So, and it tells you that the goal or your answer is going to be determined by pairing up the smallest number in the left list with the smallest number in the right list. Then the second smallest number with on the left with the second smallest number on the right, and so on. And then within each pair, you want to figure out how far apart the two numbers are. So you'll need to add up all of those distances. And so when it says how far apart they are, you want to just basically find the difference. So, the way that I implemented my solution was basically just by doing exactly what the problem told me to do. So I created two lists of numbers. In this case, since we're using Rust, they were two vectors of numbers, and I went ahead and sorted them and then subtracted one list from the other. And I was able to obtain my answer that way. So I think we're just going to go ahead and code this up. Just like last year, I'm going to continue with having the boilerplate code pre-written, just because I think it saves quite a bit of time. But anyways, so we're always going to start with basically this input that just represents the test input as a string. So we do need to parse that a little bit. So we can say let rows be equal to input dot lines, which is going to give us the lines as an iterator, and then we're going to filter these lines by going by checking for any empty lines. So the way that you do that in Rust is use these vertical brackets, and we don't want the line to be empty, of course. Otherwise, we'll fail to parse it later on. So now that we have our rows as a vector of lines, or rather an iterator of lines that are non-empty, we can go ahead and say we can define our left list and our right list. So our they're both going to be vectors, and we'll use unsigned integers because the input is non-negative. And then we'll say the right list is going to be also a vector of unsigned integers, and we'll go ahead and instantiate it. And then we'll basically just iterate through the rows. So for row in rows, we'll define our numbers to be a vector of strings. So we have to go ahead and um, kind of parse out the specific strings that we're interested in. So we're kind of throwing some input parsing into other places in the solution. It'd probably be a little cleaner to do all the input parsing in one place, but I kind of just put together the solution somewhat quickly. So No worries. But anyways, we'll say left list dot push, and we'll go ahead and take out the first number, number 0, and we want to parse it as an unsigned integer. So we'll go ahead and do that. And then we need to unwrap it. And then I'm just going to go ahead and copy this line of code and change this to right list and change this to index 1. Now we have our two lists of numbers, and as I mentioned, we do want to sort them because this is how we're going to ensure that we're comparing basically the first smallest number in the left list with the first smallest number in the right list, and so on. So we'll go ahead and do that, and they're of course guaranteed to be the same length because our input rows, or sorry, our input columns have the same number of rows. And then we'll go ahead and say our answer, which needs to be mutable so that we can actually add numbers to it. So answer, which is again going to be an unsigned integer, is just going to basically be equal to the sum of the differences between the numbers in these lists. So we'll go ahead and say answer plus equals left list I dot absolute difference with the right list. And then we can go ahead and rather than returning 0, we'll just return our answer. And then I'm going to change this to read from the test input. And I don't think I actually have copied this input in. So let me do that real quickly. So I'll go ahead and copy that in. And then, okay, I've already responded to this question, so I need to get my input again. There we go. So we have our input. And then we're going to go ahead and run this. So cargo run bin part 1. Okay, it does not like my unwrapping. What did I do wrong? So it says this is on it. Yeah. What did I do? We need to return the answer. This is returning a okay, we just need to update the return type. So okay, still does not like that. I wonder why. Oh, so the input is reading from the wrong file because I never updated it. So this is just to be competitions AOC 2024. We are in recording studio. I made like a little separate repository, or not repository, folder to do my recordings from, so I don't mess up my actual solutions. This says our answer is 11 for the test input. Looks like our answer is 11 for the test input. I'll go ahead and run it on the real input, and I'll receive my 2,176,849. That is beautiful. That is our answer. And I'm just going to go ahead and copy our code from part 1 over into part 2. Let's see how different part 2 is. So part 2 is asking us to calculate a similarity score by adding up each number in the left list after multiplying it by the number of times that it appears in the right list. Okay, so for example, the first number in the left list is 3. It appears in the right list 3 times, so the similarity score increases by 3 times 3. All right, I think that makes a pretty straightforward implementation. So, of course, we still need our left list and right list, but now we are going to keep track of the frequencies or the number of times that the values in the left list occur in the right list. So go ahead and say let frequencies be a hash map of unsigned integers, and this can be a hash map new, and I think we need to import it. So use std collections hash map. Okay, and then we have our frequencies, wonderful. And then for our in right list, let's let's frequencies dot insert, and we want to insert the, let's see, the right list value as the key, and then we want to increment the current value by 1. So actually what we can do is we can use kind of the special syntax here where we dereference the frequency hash map and then make an entry. So use the entry API, so dot entry, and we'll use R as the key, and we'll say or default. Since this kind of serves as like a default dict, very similar to Python, where you kind of you specify the type that the dictionary is going to store in the values, and then you pre-allocate the entries. so that you can just, you don't have to, or so that you can avoid checking if a key exists in the dictionary. You can just append or insert or increment in our case. Um, so then we can go ahead and say let, or we actually already defined our answer here. So our answer is still an unsigned integer for, let's say L in left list. Now we're just going to basically check if the left list value is in the hash map. And if it is, we will increment our answer by that number. So we'll say if frequencies dot contains key, and we need to pass in the key as a reference so that it can be borrowed and not stolen by that contains key function. We will say answer plus equals L times frequencies, and again, uh, passing in that L as a reference. And we'll add our semicolon, and we'll go ahead and change this to test, and we'll go ahead and say cargo run bin part 2. We get 31. That is correct for the test input. Now let's go ahead and run it on the real input. Let me change this. Maybe I should add like a parsing flag. And we get, what is this? 23,384,288. And that is our answer. So that's very exciting. We got our first 2 stars of the 2024 Advent of Code done. And I look forward to completing the rest of the 23 very soon. Thank you so much.